Assalamu alaikum. Hello, everyone. We are still in the topic of data understanding and preparation. Last time we stopped here, so we will start from case study 2. Okay, so we don't need to read through this because we're gonna go over them one after the other in the coming cells. Let's start. Okay, let me first restart and clear all the outputs. Okay, so we start by loading our data. This is our data. Okay. So let me look here first. Okay, so we have these columns here: the age, the job, the marital status, education level, default balance, housing loan, subscribed. So this seems to be some banking data. Okay, there is a mix of categorical as well as numerical attributes. And as we can see here from the printout of info, the total number of entries match the number of of the non-nulls for every column. So there is no missing data here. Okay. Yes. So now we assume like we want to prepare this data to enter it. So we are preparing it to perform some data mining or machine learning tasks. So we are going to go over all of these steps, like including transforming all the categorical attributes to numerical attributes, because most of the models take numerical attributes as an input. Okay. So yeah, we will do that, and we will do the normalization and all necessary things. Okay. Let's keep going here. So first of all, we need to define how many categories are there for every categorical attribute. Okay. Then we can actually extract those categorical attributes and then call describe for them. So let me first remove this okay, and comment out this to look at the output. We know the output of this, right? So here we are extracting the non-numerical attributes or the categorical ones, and we call describe for them. We know what describe will return, right? The statistics of those, right? So these are the 4 things: the count, unique, top, and frequency. We know this very well by now for every column. Now, if we are only interested in this in unique, okay, which actually defines the number of categories or the number of different unique values for every categorical attribute, then we can actually, after calling describe, we can extract that, and this will be a series. Okay, so if we look at this, yeah, where the labels are the column titles, and the values are the number of different categories, okay, or unique values. For example, here for job, there are 12. For marital status, there are 3. So single, married, and divorced. Education, there are 4. We will look at them. And for the others, there are 2 for each one of them. Yes or no, okay? Now, let's print the... so here, we are printing out the different unique values for the column education. So we are actually converting them to a list and then displaying them here. As you can see, there is a primary, secondary, tertiary, and unknown. There are 4 choices. Okay. Assume for our use case here, we don't want the records with unknown. We want to drop them. As I always say, things will always depend on your use case or application. Okay. Here we assume that we don't want them. So we want to drop all the records in which the value in education is equal to unknown. Then simply we extract this slice, the slice that satisfies this condition, okay, where the education is unknown, and then we retrieve the indices of those records. Okay, so we are retrieving the indices of the records in which education is equal to unknown, and then we are dropping them by calling the function drop. So we are dropping all records with those, like, yeah, all these records in which education is equal to unknown. In place is equal to true, so this change is permanent. We are changing our original data frame. Okay, so we are performing the change in the same data frame. Then if we show this again, this is what we get here. So unknown has been dropped. Okay, so we have all the records with unknown with education equal to unknown has been dropped. So we are left off with only 3 categories for that categorical attribute. Now we come to how to encode that education, how to transform or convert that to a numerical attribute. First of all, one thing we notice here, there is an order here. Primary is the lowest, secondary is higher, and tertiary is the highest. If there is an order, then we need to maintain that order. This is an ordinal attribute. We need to make sure that we perform the kind of transformation such that that order is maintained, okay? So then one way to do that is through a dictionary here, where we pass those as keys, okay, the original values, the values of the categorical attribute, and we pass the numerical corresponding numerical values as the values, okay? So we are maintaining the order here. Primary, okay, will be transformed to 1, secondary to 2, and tertiary to 3. Then we pass that. So the new version of our column is equal to the old version dot map, and we pass this dictionary here. Okay, then primary will be converted to 1, secondary to 2, and tertiary to 3. Okay, if we use label encoder will give those numbers one like 2, 3, or 0, 1, 2 based on the alphabetical order. Okay, it doesn't maintain the actual order here. Okay, so that's why we don't call label encoder. We actually use it. We like transform this attribute using this method. So we are maintaining the same order. Okay, we're not introducing an order that is based on the alphabetical order of the letters or the words. Though here it's by coincidence the order. If you perform label encoder, because P comes before S and S comes before T in the alphabetical order, if you use label encoder, you will still maintain the order, but in general, that may not be the case. So if you want to maintain the order, you want to do it this way, okay? Okay, so now this what happened. Now education has been converted to a numerical attribute, okay? Where, as I said, primary has been replaced by 1, secondary by 2, and tertiary by 3. So the order is maintained. So we're done with the first attribute. We can normalize the numerical attributes here. Okay. One thing I want to mention, okay, I usually like what we do, we transform all the non-numerical attributes to numerical attributes, and then we perform normalization. Okay. For example, for this one ordinal this ordinal attribute, it will not be, if we normalize the other like age and balance to be using, for example, min max, they will be between 0 and 1, but this will not be in the same scale. Though for this case, it's not so far from that, okay? It won't be as bad as, if, for example, if this is at thousands or something, okay? And the other ones, the yes, no ones, when we encode them using min max, they will all be between 0 and 1. And even if we perform min-max normalization after that to them, we are returning the same values. It will not change, okay? Maybe if we do z-score, it will be minus 0.5 and 0.5, but they are still okay. Okay, but since these numbers are not so far from 0, 1, it's okay to follow this. We follow this, okay? But usually, as I said, we do transfer all non-numerical attributes to numerical attributes, and then we do this normalization, okay? And maybe it's better like you, if you are using like a normalization scheme, maybe normalize all of the features using the same scheme, okay? Not different schemes, okay? Yeah. So maybe, yeah, for this one, for balance, okay, there are positive and negative values. You could use z-score for this and min-max for the age, since the age is always positive and this may take negative values. Yeah, that could be done as well. And you can try different things. You are feeding all this to your model, okay? So you can try actually all these different things and you see which model, because when you're building a model, you will testing your model in a testing data, right? So then you can try perform min-max to all. You can, for example, just use min-max for positive ones and standard scalar or z-score for ones that can have negative values, or all z-score. And you can try all these and see which model is giving you Yeah, it's it's better in terms of generalizability outside your training data. We will come to those details later, okay? Anyways, so let me, okay. So we converted the first one. It's an ordinal attribute. Now we are normalizing this one, this column, age column, okay? So we are using min-max normalization here, okay? So from scikit-learn.preprocessing, we import min-max scalar. Scikit-learn is a good library. It has many of the functions and models that we use for data processing as well as machine learning and data mining tasks, okay? So here we import min-max scalar and we perform this normalization using these three lines, okay? The first line, scalar is equal to min-max scalar. So here we are defining our normalizer. So we are creating our one instance from this class, okay? So here we're just defining the normalizer. In the second line, when we call .fit and we pass our data, here we compute the parameters, okay, the normalization parameters. For example, what are the parameters when it's min-max? Remember, min-max, we take x normalized is equal to original x minus min over max minus min. So our parameters are the min and the max. So here we compute those, okay? After the computation here, we perform the actual transformation or normalization. It's performed here using the function transform, and we pass our column that we want to perform the normalization for. That's it. And then if we display the data frame here, after the normalization, these are the values. They are between 0 and 1. As you can see, the maximum is almost 1 and the minimum is 0. Okay, now for the other one, for balance, we are actually performing a z-score normalization. So x normalized is equal to x minus mu over sigma. And they are the same three steps here. So we import standard scalar, and here we create the normalizer. We fit the normalizer using our column, okay? The data, we fit it in the data. So here we are computing the required parameters, which are the mu and sigma, okay? And here we perform the actual transformation or normalization by calling the function transform, okay? Then after, what do you expect to see after the normalization? The mean will almost be 0, and because here we are printing the mean and the max and the standard deviation, sorry. Okay, so the mean will be almost 0 and the standard deviation will be almost 1. Let's look at that here. So here, this is the balance. As you can see here, the mean is almost 0. Okay, it's 3 to the minus 17. Okay, almost 0, and the standard deviation is almost 1. Very close to 1. Okay, then for the remaining ones, we can actually use one of two techniques, because the remaining ones they take only two categories, yes or no. Okay, for if there's two categories, then we can use either label encoder, okay, label encoder, or we use one-hot encoding. Okay, label encoder will encode it into 0 and 1. And in fact, if it's 0 or 1, if it's only two categories, there's no really order here, because if you look at it from the perspective of one category, so you can look at it as 0 if the value is equal to that category, 1 otherwise, okay, or the other way around, 1 if the value is equal to that category, 0 otherwise. So when it's only two categories, we can use label encoder, okay. So and label encoder will always will replace no with 0 and yes with 1 because n comes before y in the alphabetical order, okay? So we can use that, okay? And we did use that for subscribe it. And again, we import label encoder, and here we have these three lines, okay? Here we define the encoder, we fit the encoder in our data, and here we perform the actual transformation, okay? The same three steps here. And here is subscribed is encoded into 0 and 1, okay? We can do the same for loan and housing, but for the sake of the explaining and exploring different ways, let's do them using the one-hot encoding. But actually before that, I forgot one thing here, marital status, okay? Now marital status, it's a categorical attribute, but actually there's no order here. Married, single, and divorced, there's no order there. If there's no order and the number of categories is greater than 2, okay, then we need to do one-hot encoding, okay? We do one-hot encoding by calling the function getDummies, okay? We pass this column here, marital, and we drop the first column. So here, if we don't drop the first column, it will be replaced by 3 columns, okay? Marital underscore divorced, marital underscore married, marital underscore single, because divorced comes first in the alphabetical order before married, and married before single. And then we drop the first one, the divorced, so we will end up with marital underscore married and marital underscore single. That's what we get here. Okay, so this is it. So for this one, for this record, okay, it's married. Okay, that's why this is 1 and this is 0. For this one, it's single. Okay, that's why this is 0 and this is 1. And if it's divorced, then both will be 0. Okay, we drop the first one. Okay, if we, yeah. So yeah, if we don't drop the first one, then we will have 3 columns here. Okay, so now this is encoded. The marital column is encoded. Now we come to these 3. We do them together. Okay, we can, because this function getDummies can take more than 1 column. Okay, so here for these 3 columns, these 3 columns, their content is yes or no. We can actually do it using label encoder. Okay, we can encode them using label encoder as well as one-hot encoding. Here we are doing it with one-hot encoding. So then what will happen? Default will be replaced by default underscore no, default underscore yes, but we are dropping the first one, default no. So we will end up with default underscore yes, and the values will be 0 and 1, and same applies to other 2. Let me show it here. So default yes, we will end up having only default yes, housing yes, loan yes, because we are dropping the first one for every one of them. Okay, because there are 2 categories, every one will be replaced by 2 columns, but we are dropping the first one. Okay, because this is enough, right? So when this is 0, that means the value is no. 1, the value is yes, the original value and the original attribute. Okay, before the transformation. Now we have transformed all of these to numerical ones. There is only one remaining. There is only one left, which is the job column. As you can see here, for the job, there are 12 categories. Okay, so if you want to encode those 12, then we will need at least 11 dummy variables. Okay, we need from 11, at least 11, at most 12. But now we are creating so many dummy variables. Okay, and as I said, then as the number of features increases, then you are complicating the learning process of your model. With if you have limited number of samples, then that will create an issue, because as the number of features increases, in order to avoid any the overfitting problem, you need your number of samples to grow exponentially with respect to that. One way to avoid like creating so many columns and things here will depend on your application or use case. Okay, here, for example, if you look at the different jobs we have, we can actually what are we doing here? Okay, job unknown. We are removing the job unknown. That's the first thing we're doing here. We are removing that. We are removing the records where the job is unknown. Okay, so but even if after removing that, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11. So we need to create at least 10 dummy variables. That's too much. So what we do here, we are trying to actually come up with another discrete set. Okay, you remember we talked about discretization at the top. So we're trying to actually reduce this. Okay. So how do we do that? Here. So we are mapping those kind of jobs. Seems to be there, like they are the same kind. Okay, they can be categorized as one class. Okay, unemployed, self-employed, student, and retired. Okay, we map them to C1. That's class 1 or category 1. Services. Okay, blue collar, technician, housemaid. We map them to category 2, C2. management, entrepreneur, and admin are mapped to C3 or category 3. So then the new version of that column is equal to the old version dot map, and we pass this dictionary, and what we end up having here. So we have only 3 uniques or 3 different categories, okay? C1, C2, C3. So we reduced the number from 11 to only 3. For 3, we need only 2 dummy variables, right? Then we encode this using one hot encoding. We drop the first, then we end up having just 2 columns here. Job C2, job C3. Okay, and that's it. With that, we have converted our data frame or the data itself to numerical data, and it's ready for our task. Okay, then you can save it. This is like as a clean data. You can save it, and you keep the header. Okay, you take the header, the associated header here, or the header we already have. Okay. And now it's like normalized, ready. I mean, all of the different like required manipulation, cleaning, normalization has been done. Okay. With that, I come to the end of this, and we will see later on, from topic 7, we will actually see how we will go back to data preparation. We will prepare work on preparing our data again, and then perform some tasks, including like in topic 7, we will perform or work on linear regression. In topic 8, in classification, and in topic 9, we will work in clustering. So we will see like why we have been doing all this at that time, inshallah. With that, I come to the end of this class. Thanks for watching. Assalamu alaikum.